Right now, nearly 1 billion miles from Earth, a tiny frozen moon is shooting geysers of water into space. And inside those plumes, scientists have found something extraordinary: the chemical ingredients for life. This isn't science fiction. This is Enceladus, one of Saturn's 70-plus moons. And beneath its icy shell lies a vast, dark ocean that could rewrite everything we thought we knew about where life can exist in the universe. For decades, we've looked at Mars. We've dreamed about Europa. But Enceladus is different. Because unlike anywhere else in the solar system, this moon is literally advertising what's inside it, blasting samples of its hidden ocean directly into space for us to analyze. And what we've found has sent shockwaves through the scientific community. Because if life exists in that ocean, it means life didn't just happen once in our solar system, it happened twice. And if it happened twice here, in our tiny cosmic neighborhood, then the universe might be absolutely teeming with it. Before we dive into the science, I want you to think about what this really means. We're not just talking about discovering microbes on a distant moon. We're talking about answering one of the oldest questions humanity has ever asked. Are we alone? And here's the thing. The search for life beyond Earth isn't just for scientists in lab coats. It's for everyone who's ever looked up at the night sky and wondered. If you want to go deeper into this journey, into the broader hunt for life in our solar system and what it means for our future, check the description below. I've put together an ebook that explores these questions in even more detail, expanding on the evidence, the missions, and the profound implications of what we might find. It's there for anyone who wants to keep exploring after this video ends. Because what we're about to discuss isn't just fascinating, it could fundamentally change how we see ourselves in the cosmos. So let's talk about Enceladus. Enceladus is small, really small. At just over 300 miles in diameter, it's roughly the size of Arizona. You could fit 7 Enceladuses across the width of our own moon. In the grand hierarchy of solar system objects, it's basically a footnote. For a long time, that's exactly how scientists treated it. Saturn has dozens of moons, and the big players, like Titan, with its thick atmosphere and liquid methane lakes, got most of the attention. Enceladus was just another icy rock, frozen solid, geologically dead, ancient, boring. But then, in 2005, everything changed. NASA's Cassini spacecraft made a close flyby of Enceladus, and what it saw defied all expectations. The moon's surface near its south pole wasn't just cracked, it was active. There were massive fractures in the ice, nicknamed tiger stripes, and from these stripes, enormous plumes of water vapor and ice particles were erupting into space. Imagine that. A moon that was supposed to be dead, cold, and static was putting on a fireworks show. Scientists were stunned, because where there's water erupting from the interior, there's heat. And where there's heat and water together, there's the possibility of something far more profound. Cassini didn't just observe these plumes from a distance. Over the course of its 13-year mission, it flew directly through them, multiple times. And each time it collected data that made the case for Enceladus stronger and stronger. The plumes weren't just water. They contained salts, the kind you'd expect from an ocean in contact with a rocky core. They contained silica particles, which suggested hydrothermal activity, the same kind of chemistry that happens at volcanic vents on Earth's ocean floor. And perhaps most incredibly, they contained organic molecules, complex carbon-based compounds, including some of the basic building blocks necessary for life as we know it. Let me be clear, this wasn't a trace of contamination. This wasn't ambiguous. This was a direct sample of what lies beneath the ice, delivered to us by the moon itself. And what it revealed was this: Enceladus has a global subsurface ocean, not a pocket of water, not a frozen lake, a global ocean, tens of kilometers deep, trapped beneath an icy crust that's somewhere between 20 and 30 kilometers thick. Think about that for a moment. Beneath that frozen surface, there's more liquid water than in some of Earth's seas. An entire dark ocean, completely isolated from sunlight, potentially thriving with chemistry we've only begun to understand. Now, here's the question that immediately comes to mind. How is this possible? Enceladus is far from the sun. It's out in the cold depths of the outer solar system where temperatures plunge to -200 degrees Celsius. So how does it maintain a liquid ocean? The answer is tidal heating. Enceladus orbits Saturn in what's called an elliptical orbit, meaning its distance from the planet changes as it goes around. Saturn's immense gravity pulls on the little moon, squeezing and stretching it like a stress ball. This constant flexing generates heat deep within Enceladus's interior, enough to keep that ocean liquid, but there's more. Scientists believe there are hydrothermal vents on the ocean floor. Picture the black smokers we have in Earth's deepest oceans, where superheated water, rich in minerals, spews out from cracks in the seafloor. These vents are oases of life on Earth, supporting entire ecosystems in total darkness. On Earth, we've found tube worms, shrimp, bacteria, entire communities that don't rely on sunlight at all. They get their energy from the chemicals in the vent fluids, a process called chemosynthesis. And if this is happening on Enceladus, if there are vents pumping out heat and nutrients into that dark ocean, then you've got all three ingredients for life: liquid water, organic chemistry, and an energy source. You've got habitability. Let's pause here because this is where it gets truly profound. When scientists talk about the search for life beyond Earth, they're not looking for little green men. They're looking for microbes, single-celled organisms, the kind of life that dominated Earth for billions of years before anything more complex came along. And the conditions on Enceladus are strikingly similar to the environments where life first emerged on our own planet. Early Earth was a violent place, bombarded by asteroids, with a thin atmosphere and oceans likely filled with hydrothermal vents. Life didn't start in a sunny tide pool. It started in the dark, in the deep, in chemically rich environments where energy and raw materials came together. Enceladus has that. It has liquid water in contact with a rocky core. It has organic molecules. It has an energy source. Every single box on the habitability checklist is ticked. But here's what makes it even more tantalizing. Life on Enceladus, if it exists, would have originated completely independently from life on Earth. It would be a second genesis, a separate origin, which means the chemistry of life, the processes that lead from molecules to metabolism to reproduction, might not be unique to Earth. It might be a universal phenomenon, something that happens wherever the conditions are right. And if that's true, if life arose twice in one solar system, then statistically, the universe must be absolutely full of it. Discovering life on Enceladus wouldn't just be a scientific milestone, it would be a philosophical earthquake. For all of human history, we've wondered if we're special, if Earth is the only cradle of life, if biology is some kind of cosmic fluke. Finding even a single microbe in that subsurface ocean would answer that question definitively. No, we're not alone. No, life is not rare. The universe is far stranger and more alive than we ever dared imagine. It would change astrobiology overnight. Right now, we have a sample size of 1, Earth. Every theory we have about how life starts, what it needs, how it evolves, is based entirely on what happened here. But if we find life on Enceladus, we suddenly have a comparison. We can study a completely different biochemistry, see if it uses the same genetic code, the same basic molecules, or if it's built on something entirely alien, and it's not just academic. If life can thrive in the dark, ice-covered oceans of a small moon, then the number of habitable worlds in the galaxy just exploded. Because there are moons like Enceladus everywhere, Europa, around Jupiter, Titan, Ganymede, even distant worlds in other star systems. Frozen in dark might harbor hidden oceans and hidden life. Enceladus tells us that life doesn't need a planet like Earth. It doesn't need sunlight. It doesn't need a thick atmosphere. It just needs water, chemistry, and energy. And those ingredients are everywhere. So how do we find out if there's life down there? How do we go from educated guesses to actual evidence? Right now, several space agencies are developing mission concepts specifically designed to investigate Enceladus further. NASA has proposed the Enceladus Orbilander, a spacecraft that would orbit the moon, fly through the plumes repeatedly to sample the water in even greater detail, and eventually land on the surface. The idea is to analyze the chemistry in real time, looking for biosignatures, molecules that could only be produced by living organisms. The European Space Agency is considering similar concepts, and there's even talk of more ambitious missions, sending a probe that could melt through the ice, a cryobot, and deploy a submersible into the ocean itself. Imagine that, a submarine exploring an alien sea, searching for life in the depths of another world. Of course, these missions face enormous challenges. Getting to Saturn takes years. The ice is thick. The technology to drill through it and survive in those conditions doesn't exist yet. And we have to be incredibly careful about contamination, making sure we don't accidentally bring Earth microbes along for the ride and ruin the very experiment we're trying to conduct. But the point is, we're not just dreaming anymore, we're planning. The scientific community is mobilizing, and within the next couple of decades, we might actually have the data we need to answer the question once and for all. It's almost poetic, isn't it? That one of the most important discoveries in the history of science might come from one of the smallest, most overlooked places in the solar system. Enceladus doesn't look like much. It's a pale, icy dot orbiting a distant gas giant. But beneath that surface is a world. A real, dynamic, active world with oceans and chemistry and possibly, just possibly, life. And the beauty of it is, we don't have to guess. We don't have to dig through miles of Martian soil or wait centuries for interstellar probes. Enceladus is handing us the evidence. It's spraying samples of its ocean into space, offering us a chance to look inside without ever having to land. That's why scientists are so excited. That's why missions are being planned. Because this isn't a long shot. This is one of the best chances we've ever had to find life beyond Earth, and it's sitting right there in our own solar system, waiting for us. For thousands of years, humans have looked up and wondered if the lights in the sky were just distant suns, or if they were homes to other worlds, other life, other stories. We've sent probes to the edges of the solar system. We've landed rovers on Mars. We've flown past Pluto and ventured into interstellar space. And with every mission, we've learned that the universe is far more complex, more beautiful, and more surprising than we ever imagined. Enceladus is the next chapter in that story. A tiny moon with a hidden ocean, a place where the conditions for life exist right now, beneath the ice. And if we find that life, if we confirm that biology emerged there independently, then we'll know something profound, that life is not an accident. It's a feature of the universe, something that happens naturally, inevitably, wherever the ingredients come together. And that changes everything. It changes how we see ourselves. It changes our place in the cosmos. It changes the questions we ask and the futures we imagine. So keep looking up, keep asking questions, because the universe is vast, and we've only just begun to explore it. And somewhere out there, orbiting Saturn, a little frozen moon might be about to rewrite the story of life itself. Thanks for watching.